Okay, this is going to be working out a couple of problems on an assignment for homework, and it's going to be on the area between curves. And I think we started working out problem 1 and finished it, and we started problem 2. We're going to go ahead, I believe, and try to do problems 3 and 5 from this set. And we have two curves here, y equals x squared and y equals x cubed, and we're going to try to find the area between these two curves. Well, to do this, I'm going to go from knowledge of parent function first. Alright, y equals x squared is going to be, I'm going to take this point here in blue. This will be 1 comma 1, negative 1 comma 1, and then 0 comma 0. So this curve y equals x squared is going to come like this in blue. Okay, not the greatest, but we'll call this one f of x equals x squared. And the next one we have is the cubic parent function, y equals x cubed. And for that, I'm going to draw another point at negative 1 comma negative 1. And then we're going to go through 0 comma 0 and 1 comma 1 in some fashion like this. So the graph's coming up like this, and I think it's going flatter and comes up like this. So the area between the curves is going to be just a little sliver right here. It's going to be a very small area. I'm going to draw it in purple. And to figure out what that, I'm going to call this curve here g of x. So just this little sliver between these two here in quadrant 1, that's going to be the area between the curves. And to find out algebraically what those intersection points are, we can set x squared equal to x cubed. And if we subtract x squared from both sides of this equation, x squared cancel out, we get 0 equals x cubed minus x squared. And then if we factor out x squared from both terms, we get x squared times quantity x minus 1. So we have intersection points at x equals 0 and at x equals 1. So those are our intersection points. And to work out what this is, it's going to be, where's that purple? We're going to have our area between the curves is going to be the integral of the function on top, which is f of x equals x squared, minus the function on bottom, which is g of x equals x to the third power. So here we have x squared minus x cubed and dx. And we're going to go from 0 to 1 because we've established our limits of 0 to 1 right here, as well as graphically on our drawing. And so working out the integrating, we're going to have x to the third power, we raise that second power to 3 and divide by 3, minus x to the fourth divided by 4. And here we're going to go between 0 and 1. And that's going to equal 1 times, that'll be 1 to the third power over 3 minus 1 to the fourth power over 4. And this is going to be, and then the next thing we do is we subtract out 0 to the power of 1 minus 0 to the power of 4, which is going to be 0, so we don't have to worry about that. This is all we have to deal with. So we're going to have 1/3 minus 1/4. And our common denominator between these two, 3 and 4, is 12. So 1/3 is going to be 4/12, and 1/4 is going to be 3/12. So our answer is going to be 1/12. That is the area between these two curves. We can see it is a very small area. Let's go on to number 5. Okay, number 5, we have y equal 1 over x squared and y equals 0 between x equals 1 and x equals 5. Well, if we graph 1 over x squared, that's going to look like, I'm going to just kind of leave it like this over on the left. The function is going to look something like this. Okay, this is going to be what 1 over x squared looks like. You have sort of this, then it's going to come down like this. And we're interested between x equals 1. Okay, here's x equals 1 and x equals 5. And so we're interested in this little sliver right here. Okay, so between this function, which is y equals 1 over x squared, and y equals 0, or the x-axis. There's 5 and 1. So what we have is the function on top is going to be this 1 over x squared. So to find the area between the curves, we're going to go from our limits given of 1 to 5 of 1 over x squared. I'm going to write this first before. Minus 0, right? Y equals 0. And then that's going to be dx. And writing this in the calculus-friendly form, we have between 1 and 5. Okay, between 1 and 5 of x to the negative 2 power dx. And this is going to be equal to, integrating, we add 1 to negative 2, so we're going to get x to the negative 1 power, and we're going to divide by negative 1. And for that, and we're going to go between 1 and 5. So that's going to be the same as negative 1 over x between 1 and 5. For that, if we plug in 5 for x, we're going to get negative 1/5, and then we're going to have minus negative 1 over 1. So that's going to be the same as negative 1/5 plus 1, which equals negative 1/5 plus 5/5 equals 4/5. And that's going to be our answer for problem number 5. Let me write this down, make it a little more legible. Okay, these numbers should be pretty easy to work with. I can't really understand well enough from my knowledge of the functions to see how reasonable an answer this is. I'm going to just check it briefly in my calculator, make an annotation if there's anything different, or redo this video if there's something different. Anyway, good luck to you, and thank you for viewing.